So hi guys, welcome back to another videos for calculus 2. So on the recent video we already talked about integration by parts, which is a really strong technique to evaluate a complicated integrals. So now we will moving on to another topics after integration by parts, and it's also about evaluations of integrals. So this actually not a techniques, but it's help you to solve the integral that has trigonometry on that. So it's called trigonometry, the trigonometric integral. So we will talk about trigonometric integrals. So first we will look at integrals of trigonometric function beginning with power of sine and cosine. So we will recall some of the basic equation about trigonometry. So the first one you guys will really familiar with will be sine square of theta plus cosine square of theta equal to 1. And then from this one you can have like you can have two more equations, and it will be tangent square to the power tangent square of theta plus 1 equal to secant square of theta. So basically moving from the first one to the second one, you just divide both sides by cosine theta square, and it will give you the second one. You divide both sides of the first one by cosine theta square, and it will give you the second one. So and the last one will be 1 plus cotangent of theta square equal to this one. So the same thing, you can go from the first one to this one. So you just divide both sides by sine theta square, and it will give you this one. So um all of the thing that you need to remember is the first one, and you can um y- you can have the second and the third one by doing basic algebra. So this is some basic equation about trigonometry. So moving on to the first example of this video. So we will evaluate the integral of sine of x cube sine dx. So for this one, you um you have a really big powers, and it is 3. So you have to down it to break it down to like simpler um polynomial, I mean, yeah. So on this case you will rewrite this integral to this form. You will break it to sine multiplied by sine square dx, and you remember this equation. You will apply it to here. You will substitute sine square of x, and sine square of x will equal to 1 minus cosine square of x. So you go ahead and substitute this to the integral, and it will give you integral of sine x multiplied by 1 minus cosine square of x dx. And from this you will use this method of substitution. And what will you what you will what will you substitute? You will substitute, so you will let u equal to um to cosine, right? Cosine square of x. So let's say if you substitute, if if you let u equal to 1 minus cosine square of x, so du will equal to 2 cosine x and multiply by a minus sine of x, right? So it will give you 2 sine x cosine x, right? But on this case you only have sine x, so you cannot use this substitution. So you have to change, you have to let u be a different value. So on this case you will let u equal to cosine of x only, not 1 minus cosine square of x. So let's try it. So let u equal to cosine of x. So you have du will equal to minus sine of x dx, right? And you go ahead and change this integral um, to the new integral with respect to u. So you will go ahead and so let's say this is a, and a will equal to integral of so du equal to minus sine of x. So minus du will equal to sine of x dx, right? So you have minus du, and then 1 minus cosine square of x will be 1 minus u square. And then this is really easy integral that you can evaluate by using by using the table of integration. So it will equal to u square minus 1 du, and it will equal to u cube over 3 minus u plus c. And then you substitute cosine back to this integral, and it will give you a cosine cube of x over 3 minus cosine x plus c. So this is the answer for this problem. So now moving on to a next example. So on this example, it's will be harder. So example number 2, evaluate the integral of cosine to the power of 4 theta d theta. So let's recall some identities from trigonometry. So on the earlier of the video, I already talked about this identity, and it's really useful and really important in calculus. So now we will recall another identities, and it will be sine of 2x will equal to what? Equal to 2 sine x multiplied by cosine of x, right? And then the another really important identity will be cosine of 2x. This will give you cosine square of x minus sine square of x, and you have cosine square of x plus sine square of x equal to 1. So you can make a change from here. You can isolate sine square into one side, and the other side will be about cosine square, and it will give you, and then substitute back to here, and this will give you 2 cosine square of x minus 1 and equal to 1 minus 2 sine square of x. You can see it, right? So let's do it really thoughtfully. So you have sine square of x will equal to 1 minus cosine square of x, right? From this one, from this identity, and it will equal to 2 cosine x minus 1, and it is what I perform here, what I show you here, and do the same thing for sine square of x. So this is like a really important identity of trigonometry, so you have to remember it. So let's apply this one into this integral. So most of the time when you see a really big power, it can be power of 3 like the previous example. It can be this example, which is power 4. You have to, break it down to a smaller power. You can break it down to 2, break it down to 1, but yeah, you have to break it down so that you can evaluate the integral more easily. So in this case, you will use this identity. So you have cosine of 2 theta will equal to 2 cosine square theta minus 1, right? And then you will isolate cosine square of theta in one side, and the other side will be about cosine of 2 theta. So let's go ahead and do some basic algebra here. So it will be cosine of 2 theta minus 1 will go back, go to the left, and it will be plus 1 and divided by 2 equal to cosine square of theta. So but in this case you have the power of 4, so you'll go ahead and square both sides of this equation, and it will give you an I mean actually you can substitute to the integral over here, so you can go ahead and substitute it. So we have cosine to the power of 4 of theta d theta will equal to the integral of cosine 2 theta plus 1 over 2 and square, because over here you only have cosine to the power of 2, but the problem is about cosine to the power of 4, so you have to square it, and d theta over here. And so next I will take the 1/2 square out, and it will give me 1/4 integral of cosine 2 theta plus 1 square d theta. Is it clear over here? Because I take the 1/2 square over here out of the integral, and it will give me 1 to the 1/4 and multiply by the integral of cosine 2 theta plus 1 all square. So I think it's clear over here. So next one I will you remember this one, a plus b square will equal to a square plus 2ab plus b square, right? It's a from algebra from high school. So I will go ahead and use it and break it down this one. So it will be 1/4 integral cosine square of 2 theta plus 2 cosine of 2 theta plus 1 d theta. And for this one, you will use the identity that I show you here. You would use the same thing, but this in this case it will be 2 theta, not only theta. So it will be cosine 4 theta equal to cosine 2 theta, cosine square of 2 theta plus I mean minus 1. So isolate cosine square of 2 theta, it will give you cosine of 4 theta plus 1 over 2, and then go ahead and substitute back to our integral, and it will give you cosine of 4 theta plus 1 over 2 plus 2 cosine of 2 theta plus 1 d theta. And you see we going from a really big power, the power of 4, and then we now only have power of 1, so it's really easy for us to find the value of integral. So let's now use the let's now simplify it more. So cosine of 4 theta over 2 plus 2 cosine of 2 theta plus 1 half plus 1 will be 3 half d theta. So now find the integral. So cosine of 4 theta will from sine 4 theta over 4 and multiply by 2 because we have 2 over here. So and then plus 2 sine 2 theta over 2 plus 3 half theta d theta. Oh no d theta, and then plus c, the constant from inside the bracket. It's just the same as it's when it's moved outside the bracket. It's just the same. Constant can be any number, so it doesn't matter where we place it. So so now let's simplify it much more. So you have so 4 multiply 4 multiply 2 will give you 32, and then sine of 4 theta plus 1/4 of sine 2 theta, and then plus 3 over 8 theta plus c. So the answer will be here. So you can see on most of the problem about trigonometry, it will give you a really big power. It can be 3, it can be 4, and your main goal is to break it down to simplify it to a product of a series of a first power. What I mean. So yeah, so this is the example number 2.